Hey everyone, welcome back to the channel. In today's video, we're going to talk about one of the most common issues in the HVAC field, when a heat pump or chiller trips on high pressure or low pressure alarm. We'll go through what these alarms mean, the most likely causes, and the right troubleshooting steps you can take in the field. Let's get started. Every heat pump or chiller has two main sides of the refrigeration circuit. The high pressure side, which includes the compressor discharge and condenser, and the low pressure side, which includes the evaporator and the suction line. When pressure gets too high or too low, safety sensors or pressure switches will shut down the compressor to protect the system. A high pressure alarm happens when the refrigerant pressure in the condenser becomes too high. In simple terms, the refrigerant can't reject heat properly with the air or water. Here are the most common causes: dirty or clogged condenser coil in an air-cooled system, and condenser fan not running or running at low speed. In a water source system, low condenser water flow, closed valve, or a dirty or clogged condenser heat exchanger. Overcharged refrigerant, or the presence of non-condensable gases like air in the refrigeration circuit. High outdoor ambient temperature, or poor ventilation around the unit. Troubleshooting steps: check condenser coil cleanliness and fan operation. For water source units, check water flow rate, strainers, and isolation valves operation. Verify the refrigerant charge, if solenoid valve stuck, and if four-way reversing valve working properly or not. Make sure discharge pressure is within manufacturer limits, usually around 350–450 psi for R410A systems. Reset the alarm only after correcting the cause, not before. In this picture, you can see that unit went on high pressure alarm. The condenser water loop temperature is not bad as well, so what might trigger the high pressure alarm? These photos clearly show contaminated and heavily corroded condenser water, with visible rust flakes, scale, sludge, and dirty water, and that directly explains why the heat pump is tripping on high-pressure alarm. In a water-to-water or air-to-water heat pump, the condenser water loop, hot side, is supposed to carry heat away from the refrigerant. When the water is dirty, rusty, or contains debris, several things happen. Rust particles, scale, and sludge settle on the inner walls of the brazed plate or shell-and-tube heat exchanger. This creates an insulating layer between the refrigerant and the water. The refrigerant can't reject heat efficiently. Discharge, condensing temperature rises rapidly. The debris, like what's seen in the images, clogs Y strainers, isolation valves, or even microchannels inside the condenser plates. This reduces flow and increases differential pressure across the heat exchanger. The refrigerant pressure climbs even faster due to poor heat transfer. A low-pressure alarm means the suction pressure in the evaporator is lower than normal. This usually happens when the system isn't absorbing enough heat from the air or water loop. Common causes include low refrigerant charge due to a leak, dirty or frozen evaporator coil, high water flow through the evaporator, expansion valve stuck closed or restricted, operating in very cold ambient conditions without proper control adjustment. Troubleshooting steps: check for airflow or water flow issues first. Clean filters, check pumps, and verify valves are open. Inspect the evaporator coil and ensure it's not iced over. Check superheat or subcooling to verify refrigerant charge. Inspect the expansion valve, solenoid valve, four-way reversing valve for blockage or malfunction. If you suspect a refrigerant leak, use a leak detector and recharge the system after repair. Recommended corrective actions: isolate and backflush the condenser loop, install or check strainer. Perform chemical cleaning. Check for proper mesh size on strainers. In the picture, you can see that we have low pressure alarm on the heat pump. High flow and low delta T on the evaporator loop, meaning possible low pressure alarm. The evaporator, water to refrigerant heat exchanger, transfers heat from the water loop into the refrigerant. When flow is too high, the water passes through the evaporator too quickly. The temperature difference, delta T, between water entering and leaving becomes too small. The refrigerant absorbs less heat per pass. As a result, the refrigerant may not vaporize fully before reaching the compressor suction, causing low suction pressure, low side pressure. The controller will detect this as a low pressure alarm or low evaporating temperature alarm. In short, high water velocity in evaporator, reduced heat absorption, low suction pressure, low pressure alarm. High pressure alarms usually mean the system can't reject heat properly, while low pressure alarms mean it can't absorb heat properly. In both cases, start with the basics. Check airflow, water flow, refrigerant charge, and cleanliness of coils or strainers. Always take readings from your gauges or controller trends before resetting alarms. Proper diagnosis prevents repeat shutdowns and protects your compressors. Thanks for watching. If you found this helpful, hit the like button, subscribe, and share this video with other HVAC professionals. See you in the next one.